Hi to all the Form 5 students. Today I would like to discuss the module learning at home. Okay, as you know, this module is in Bahasa Malaysia, so I will translate it into English. So I hope I can help you to understand or help you to learn additional maths in English by using this module. So the topic that I will focus to is chapter 8, which is probability distribution. So for probability distribution, we have binomial distribution and normal distribution. So for binomial distribution, I had discussed in my previous video. So today I will focus on normal distribution. So normal distribution is a bit challenging compared to binomial distribution. Okay, but I think after you get used to the calculator or the buku sifir, it will be quite easy. Okay, if we practice more, it will be even more easier. Okay, for binomial distribution, okay, this one we have discussed in my previous video. We have the discrete random variable, remember? We have the countable variable, whereby the variable is in integer. Okay, for probability distribution is under statistic component, so it's considered quite easier compared to other topic. Okay, so today we will focus on normal distribution. Okay, for binomial distribution, I think majority of you can score 5 marks for paper 2 section B, right? You just use a formula, Bernoulli formula, remember, or we call as the binomial distribution formula. So for this subtopic, you can master well, you can get 5 marks or maybe sometimes 4 marks for paper 2. So you want to get 10 marks, you have to master the normal distribution. So for normal distribution, we will learn how to describe the continuous random variable using the set notation. We also must know how to find the probability for the normal distribution, okay, when the z-score is given. And also you must know how to convert the x to z. Okay, the x is normal distribution variable, and the z-score is a standard normal distribution variable. Okay. Okay, guys, for the normal distribution variable, we have one is called as normal one, we call as x, and then we have one more is standard one. So now we start with the x first. X is actually the normal distribution variable. It is not the standard one. So when you look at the bell shape, the graph or the curve, it's actually a curve looks like a bell, okay? And you notice that at the vertical line there is always symmetrical at the vertical line, and the vertical line is always x equal to the mu. Mu is the mean, okay, mean of the x. X is actually the variable, okay, normal distribution variable. So the area under the curve, under the bell, is always 1. This is because the probability value is always 1. Okay, it must be 1. Okay, total area for the bell shape is 1. So the x is actually the variable for the normal distribution. So normally we will represent the symbol n, mu, variance. Okay, variance is standard deviation squared. Then, okay, for the normal distribution variable, if you convert to standard one, the mean now is 0. Okay, the mean must be 0. And then the standard deviation must be 1. Okay, it is must 1 for standard deviation. So today we will learn how to read the probability value from the bell shape. Okay, we'll learn how to use a calculator next lesson. Maybe today we just use a buku sifir. Okay, in SPM exam, your teacher will prepare the buku sifir for you on the table. or maybe in the question paper itself, they will print the buku sifir, one page of the normal distribution table for you to refer. So we have fx and fz. So if function of the x and function of z, we must know that x is a normal distribution variable and z is the standard normal distribution variable, and their relationship is z is equal to x minus mean over standard deviation. That is how you convert the x to z, by using the formula, or we call it their relationship lah. Relationship is actually formula. So when you look at the graph, you notice that for x at the middle, it must be the mean. It must be symmetrical with the x equal to mean. For standard one, your bell shape must be symmetrical when x equal to 0. When x equal to 0, it is at the vertical axis, we call as y-axis, but here we call as fz. Okay, fz, because we don't have y here. So please remember, z is the standard normal distribution variable, and x is you haven't standardized yet. Okay, in other words, x is actually the variable that you measure, like height example, or mass of something, or maybe something that you measure. Okay, and the z is after you apply into the formula, you use x minus mu over standard deviation. Okay, please look at the formula, how you write the x is always x normal distribution and then mean and then variance. Okay, but for z, you notice that we use n and 0, 1. Okay, the mean must be 0, the standard deviation must be 1. Okay, this is very important. So you must know how to do conversion. Okay, just apply the formula for z-score, the one in yellow color. Z equal to x minus mu over standard deviation. This formula will be given in exam. So, but I think it's quite a simple formula. So the z is the score that we call standard score. Sometimes we don't say standard score, we call as z-score or z-score. Okay, and x is the normal random variable. Okay, and the mu here is the mean for the normal distribution. Okay, all this will be provided by the question. Mean, standard deviation is the is 1 for the normal, for the standard one, normal distribution. So in exam they will give you variance, sometimes they will give you standard deviation. So the characteristic of the standard normal distribution graph n0, 1, mean must be 0 and standard deviation must be 1. Okay, very important. So the characteristic of the bell shape is the probability represent area under the bell shape. So the one shaded in green color is the area, and the area representing the probability for the z more than a. A is the z-score on the we call as x-axis, but it's z-axis. Okay, now for the area for one whole bell is 1. Okay, because the probability for the sample space must be equal to 1. So okay, please remember, area for one whole bell shape must be 1. In other words, area for half of the bell will be 0.5. You divide by 2 because it is symmetrical at the x equal to 0. So for the graph, characteristic number, the next one is the graph must be symmetrical. So if you find the area for the bell, for half of the bell, to the right it must be 0.5, and to the left is also 0.5. It's exactly symmetry. Okay, at the x equal to 0, mean equal to 0 for z-score. Alright, so for z more than 0 is 0.5 because at the middle is x equal to 0. More than 0 is to the right. Okay, less than 0 is to the left. So the area for half of the bell to the right or to the left is 0.5. So the area must be always positive. Okay, because the probability value must be positive. Okay, minimum is 0, maximum is 1. Okay, so the answer make sure is positive. Only the z score will be negative or positive. So when you do, please double check your probability value must be positive and the value must be below 1, okay, greater than 0. Okay. For z, okay, we see the next characteristic number 4. For probability for z more than a is equal to probability for z less than negative a. Okay, because it is symmetrical. So you just imagine that you cut and paste the bell shape is exactly the same, the area. Alright, so because of the characteristic of symmetrical, so the area for the negative one and the positive one will be equal, and the area representing probability value. Okay, so this is the we call it Sheffield Taboran normal PRY, okay, standard normal distribution table. Okay, table. So this piece of normal distribution table, standard one, will be given to you in SPM exam. Sometimes it's just attachment behind the booklet lah, so you can refer and use it. So all the data will be provided. So at the table you can see there are z score at the corner, the left side corner, and the top part, the first row, okay, is z score. Okay, so when you use a table, you need to be very careful. Always use a long ruler, okay, 2 pieces of ruler to guide you to read lah, because you tend to make mistake because there are so many small figure there. Okay, they try to squeeze in all the data into one table. So sometimes you will see that is 0.0 square. The square doesn't mean that it's square, it's 0.00, or 0.0 cube, it means that 0.000. Okay, so the table in such a way that they want to save the space so that it looks nice, the table in one page. Okay, so the table below you can see there is a bell shape. Okay, the bell shape is telling you that area under the bell represent probability value, and you observe the bell shape, the area shaded is always shaded to the right. That means the z score that you use, okay, to read the probability must be positive. Even though you got negative z value, you must make it positive because the area is symmetrical. So you have to make it positive, then you read the probability value for z which is negative. Okay, so remember the z score can be negative or positive when you read the area. Okay, the area is always to the right. Alright, so today I will teach you how to use a buku Sheffield to read the probability value. Okay, we can read in forward and backward. Forward means that I give you z score, then you read the probability value. Okay, backward means you do reverse way. That means I will ask you to find the z score, I will give you probability value. Alright, so let's see the example here. We have 3 example. The first one is find the probability from 0.4 to 1.2 for z score. It's in between. When it is in between, you have to minus from -1 to 2.5. Okay, one negative, one positive, and both negative, -1.3 to -0.5. So the first step, you want to read the probability value for the z score. You have to sketch a bell shape. so that you have a clearer picture whether you need to minus or whether you need to use 1 minus or 0.5 minus. So only when you sketch a bell shape, okay, you can read the probability value accurately. So please always make a habit to sketch a bell shape before you read. Okay, so after you sketch a bell, you use a buku sphere to find the probability value. Example here, you'll find 0.4 and 1.2 first. Okay, the smaller the z-score, the bigger the probability value. So because you see the bell shape, when it close to 0, the probability is higher. Maximum it happen at 0. Okay, when z equal to 0, the probability is highest. So in this case, we'll take the z-score 0.4 that you read from the buku sphere, okay, minus the z-score which is 1.2. Okay, then you find the difference between them. Understand? So you go to your buku sphere, you find 0.4, you read is 0.3446. You go to buku sphere, you find 1.2, you get 0.1151. So you take 0.3446 minus 0.1151. Means that the area for 0.4, more than 0.4 is bigger, which is 0.3446, and area for 1.2 is smaller. Okay, for z-score more than 1.2 is just 0.1151. So you find the difference between them, you get 0.2295. Okay, so if you sketch a bell, you notice that you just imagine that you cut out the 1.2 from 0.4, you get the balance from 0.4 to 1.2, right? So that is the meaning why you need to minus, you cut out the balance. Okay, so the answer for probability from for z-score from 0.4 to 1.2, in between, is 0.2295. Okay, now if you want to use a calculator, there are 3 type calculator. For the latest one, the new calculator, you have to use a limit, upper limit and lower limit. Okay, so for this case, okay, if let's say I ask you to find the probability value from negative value, negative something to positive something. So okay, you use a buku sphere, you make it positive first, make your z positive first, then you read. Okay, so let's say it's from negative 1 to 2.5. So you go to buku sphere, you find the z1 is 0.1587, and you find for 2.5 for z is 0.00621. So you have to take 1 minus, okay, 0.1587 minus 0.00621. Why? You look at the bell shape, you understand why you need to minus. Okay, so reading from the buku sphere for and 2.5 is 0.1587 and 0.00621. It means the area under the bell shape. So because you want to get between negative 1 to 2.5, that is why you have to minus. You use 1 minus 0.1587 minus 0.00621, and your answer is 0.8351. Okay, that is the area shaded in green color. So you label accordingly. Make sure you really label your bell and you understand why you need to take 1 minus, the left one and the right one. Okay, so if let's say you have both negative, from negative 1.3 to negative 0.5, so you sketch first, continue with finding the probability for z more than 0.600, and probability for z less than negative 1.24, and probability for z more than negative 1.1, and probability for z less than 0.76. So for this one is quite simple. If more than, you will shade to the right, less than, you will shade to the left. So from the buku sphere, you just read the 0.6, you'll get 0.2743. So for more than, you can always read directly because our buku sphere is always more than, also to the right, shade to the right. So the answer is 0.2743. Okay, for probability for z-score, which is for B, okay, probability for z-score which is less than negative 1.24. If it is less than negative 1.24, we will make it positive because our buku sphere only can read the positive z-score. So we make it z more than 1.24 because it is symmetrical. Negative, less than negative 1.24 and more than positive 1.24, the area is the same. So we just go to the buku sphere and read 1.24. Okay, the area is 0.1075. Okay, when you read, you make it positive first. So be careful when you read, and make sure your probability value is always positive when you write your probability. So the answer is the same for 0.1075 for both less than negative 1.24 or more than 1.24 are having the same area. It also means that they are having the same probability value. Okay, so if you sketch a bell shape, you can have a very good picture about the probability value. Okay, so please always sketch the bell shape, right, before you read the probability value so that you won't make careless mistake. So in the buku sphere for the normal standard distribution, all the z are positive. So make sure you still got one more question. Probability for z-score more than negative 1.1, which is equivalent to the whole bell minus the area for P. So area for P, okay, is you start from negative 1.1 and you shade to the right. You notice that it's almost more than half of the bell. So that means you have to take 1 minus 0.1357. So this one is you read the buku sphere for 1.1. So you get your answer, which is 0.8643. Okay, because the area for less than 1.1 is just 0.1357. Okay, and then for D, we want to find the probability for z-score, which is sketching of the bell is very important. Okay, for probability for z-score less than 0.76, we will read the buku sphere 0.76, you get 0.2236. So also the same, you take 1 minus 0.2236 and you get 0.7764. Okay, and you understand why you need to minus. Okay, because the one shaded in green color is referring to z-score less than 0.76. So our buku sphere only can read the right hand side, right? So we will read the 0.76 and then we minus. Okay, now the most challenging one is finding back the z-score when you are given the area or probability value. So if they give you probability value, that means they give you area. So the moment you want to do this kind of question, you always start with a bell shape, okay, and you always study the probability value. If the probability value is less than 0.5, like here is 0.4400, right? So if less than 0.5, you sketch to the right, but make sure it's less than half of the bell. So that means your K will be more than 0 point something. So you shade the bell shape first. Okay, shade to the right, but when you shade, you make sure it is less than half of the bell. Okay, so now we shade first. Make sure it's shading to the right and make sure it's less than half of the bell, because our probability value is just 0.4400. And then we'll use a Bukusi field. The probability value inside the table is the probability value, and the first row and the first column are z-score. Okay, so highlight the 0.44. If you cannot find 0.44 exactly, you find the number that close point 0.44. So we can only find one number, which is 0.440 something, isn't it? 0.4404. So later you have to minus out your the balance that you don't want. So when you minus out the balance that you don't want, you have to plus to the z-score. So always use a red pen, you circle in red color for the probability value that is close to 0.44. Okay, and then you draw the blue line pointing to the first column and the first row on top. So the first column is actually 0.1, that is your z-score, and then from the top of the 0.44, that is z-score also. So you will read out 0.1 something, right? 15. Okay, so you write down, but because you need to do some adjustment, we say, so you cannot just write 0.15 because you have extra of 4. So the extra of 4, it carry the z-score value 1. The 1 there, it means that 0. Okay, it's not 0.1. So you cannot write 0.15 because the 1 there is carry the value of 0.001, 3 decimal. So you have to take your answer 0.15 plus the 1. So it's 0.151. Okay, that is the answer for probability for Z more than K. Okay, the K itself, the value is 0.151. Okay, you can use a calculator to press back and check whether you are getting the probability value, which is 0.4400. Okay, because the Bukusi field there, they give you not exactly 0.4400. They give you what? Can you read out? They give you 0.4404. So you have to minus out the extra of 4 because our question don't have 4. We only got 0.4400. So when you minus out the 4, you have to plus 0.001. So it means all your answer must be 3 decimal places. So the probability for Z more than K is 0.4400. The K is 0.151 because 0.4404 need to minus out 0.0004. Then only you can get 0.4400. So when you minus out, you have to plus 1. Okay, so it will be, the K will be 0.151. Okay, from the Bukusi field, the K is 0.151. Okay, probability value, you use a red color pen. Z-score, you use a blue color pen. Okay, so you always follow the step. Example here, we have the area, which is 0.7294 and 0.2709, the area. Okay, now we want to find the area that close to, we can only find less than 0.5 for Bukusi field. So you cannot find from 0.7294. We will find the 1 minus 0.7294. So you can only read for Bukusi field 0.2709 because the area are actually sharing the same z-score. So we will use an area which is less than 0.5 to find the z-score. Understand? So you go to your buku sphere, the inside one, you use a red pen, you circle, okay? All the probability value you use a red pen. All the z-score you use a blue pen. Then you won't confuse. Finally, you have to always bear in mind that it is negative based on the shaded bell shape. So always shade the bell shape so that you are aware whether your z-score is positive or negative. Okay, I think I will stop here. Let's continue for next video. Bye.
静静的你开放在幽谷，空中飘逸着清香，冲着凉风，唱着白云，不知不觉地流布人间。